Regions. You can use shading on graphs to identify regions that satisfy linear and quadratic inequalities. The graph shown here is a sketch of the graph y equals fx. If y is greater than fx or y less than fx, then the curve y equals fx is not included in the region and is represented by a dotted line. So if you take a look here, all the shaded points in this region satisfy the inequality y is greater than fx, and all the unshaded points in this region satisfy the inequality y is less than fx. Y less than fx represents the points on the coordinate grid below the curve y equals fx. And if you take a look here, the shaded region shown here satisfy the inequality y greater than or equal to fx, and the unshaded region satisfy the inequality y less than or equal to fx. Here, the curve y equals fx is included in the region and hence is represented by a solid line. So let's take a look at a few examples. On a coordinate grid, shade the region that satisfy the inequalities y is greater than x minus 2, y less than 4x, and y is less than or equal to 5 minus x. So first, let's take the graph of y equals x minus 2. When x equals 0, y equals minus 2, and when y equals 0, x equals 2. So, the graph y equals x minus 2 crosses the x-axis at 2 and y-axis at minus 2. Now here's the graph for y equals x minus 2. So y is greater than x minus 2 and hence the line y equals x minus 2 is not included, so it is represented by a dotted line. Y is greater than x minus 2, so this includes all the points above the line y equals x minus 2 as shown by the shaded region. This is the line graph of y equals 4x and is represented by a dotted line as y is less than 4x. So this includes the region below the line y equals 4x. Now let's draw the graph for y equals 5 minus x. When x equals 0, y equals 5, and when y equals 0, x equals 5. And hence this is the graph of y equals 5 minus x. As y is less than or equal to 5 minus x, the graph is drawn with a solid line. Y is less than or equal to 5 minus x, so this includes the region below the line graph y equals 5 minus x, including the line graph y equals 5 minus x as shown by the shaded region. Now as you can see from this graph, all the shaded regions overlap in this particular region and hence this is the region that satisfies all three inequalities. Y is less than 3 minus x times 2 plus x and y plus x is greater than or equal to 3. On a coordinate grid, shade the region that satisfies these two inequalities. So first let's take y equals 3 minus x times 2 plus x. When x equals 0, y equals 6, and when y equals 0, x equals 3 or x equals minus 2. Y plus x is greater than or equal to 3. Rearrange it so that y is greater than or equal to 3 minus x. Now for y equals 3 minus x graph, when x equals 0, y equals 3, and when y equals 0, x equals 3. So draw a dotted line for the curve y equals 3 minus x times 2 plus x and a solid line for y equals 3 minus x. As y is less than 3 minus x times 2 plus x, this includes the shaded region below the curve. Y is greater than or equal to 3 minus x and hence this includes the region above the line graph y equals 3 minus x, including the line graph itself. The two colored regions overlap in this area and hence this colored region is the region that satisfies the two inequalities. Y is greater than x minus 3 squared, y plus x is greater than or equal to 5, and y is less than x minus 1. Draw a dotted line graph for y equals x minus 3 squared. So here is the graph for y equals x minus 3 squared. As y is greater than x minus 3 squared, this includes the region above the curve y equals x minus 3 squared. Rearrange y plus x is greater than or equal to 5. So y is greater than or equal to 5 minus x. Draw a solid line for y equals 5 minus x. As y is greater than or equal to 5 minus x, this includes the graph and the region shaded above the line y equals 5 minus x. Now, draw a dotted line for y equals x minus 1. Y is less than x minus 1 and this includes the area below the line graph y equals x minus 1. As you can see, this shaded area is the only part that satisfies the three inequalities.